Good morning, afternoon, or whatever time you're listening to this. I'm Patrick Degener from the School of Engineering, and this lecture is on how to use AI responsibly. In this lecture, we will cover artificial intelligence based on large language models, how it is changing society and engineering, and how to use it properly. As per all your lectures, the learning outcomes match the accreditation of the higher education program known as AHEP. There are various definitions in the field of artificial intelligence, or AI. It should be noted that we are talking about LLMs, large language models, and not AGI, artificial general intelligence. That is perhaps some years or decades away. The other term that is perhaps not obvious is GPT, the generative pre-trained transformer. This is the model architecture that allowed neural networks to scale to extremely large sizes used in the modern large language models. These days, everyone and their little furry pussycat is trying to pretend they are AI engineers. And who can blame them? There's good money to be made in the AI space. However, let's use cars as an analogy. You can learn to drive a car. That would make you a car driver. You can learn to repair a car. That would make you a car mechanic, i.e. a technician. Or you can go to university and learn how to design a car. That makes you an automotive engineer. In other words, folks, learning to drive a car does not make you an automotive engineer. And guess what? Learning to use an AI tool does not make you an AI engineer. And that's fine. You guys can be electronic engineers, you can be power engineers, you can be, biomedical engineers, whichever discipline you're going into. You do not need to be an AI engineer, but you will need to know how to use AI tools. We are engineers. We believe in facts, logic, and truth. But business is about making money. As such, all technologies go through what is known as a hype cycle. For years, the technology will be quietly developed in universities. Then something happens and it becomes exciting. Lots of people jump in and invest, and then realize, well, actually, it's not as good after all. The field collapses into what's known as a trough of disillusionment. But eventually, it'll come up again and it will form a useful product. Now, OpenAI invented the GPT architecture back in 2018. But the real excitement only happened in November 2022 with the release of ChatGPT. And here we are at the minute with loads of exciting investments all over the place in AI. Perhaps we will go down again from a commercial perspective, but also perhaps, unlike previous tech bubbles, the utility of AI tools is truly world-changing, and the technology development is incredibly rapid. So progress might not be as fast as the hype is suggesting, and there probably will be some bursting of a bubble, but AI is with us and will continue to be with us, and progress will be rapid from this point. Doctors Ali Kari and Shafiq will do an excellent job in teaching AI on their AI module, which is too long to repeat here. But let me give you a 90-second concept attempt. Imagine you are blind and hiking up a mountain with only a talking altimeter to tell you what altitude you are. How do you know if you're going up or down? You could take readings every couple of footsteps and then put those readings into a linear array in our memory. And if we simply subtract the previous value from the current value and divide by the step distance, we would get the gradient. Positive is up, negative is down, and bigger numbers mean bigger gradients. We could also create a simple neural net to do this. With two input values, we multiply each of these values by synaptic weights and add up the result. Then the threshold will determine whether we're going up or down. Now, if we insert the values, from our little mountain range over here, we get what we get. The mathematics in AI architectures honestly do not get much more complicated than this. At its core, it's just a bunch of multiplications and additions. So what is complex are the networks themselves, and they do get very complex. And the real challenge is actually to determine the optimal values for the synaptic weights. We can work it out logically, as we've just done here, but usually AI systems need to determine those weights by going through what is known as training. Hence, an AI model is only as good as the information you put into it, also known as the training set. Now that you've got a vague idea of what a neural network is, let's consider large language models. If we were in a class, and not in this set video, I would invite you to play a game called Hangman. This is a game where you have to guess the letters in the following words. If you get the letters wrong, I would draw a body part on the hangman. If you get it correct, I would put letters into the subsequent word slots. We can also play this game with words instead of letters, words in a phrase. And LLMs, large language models, are essentially playing that game. They are playing Hangman. They try to predict what should come next in a sequence of text. The outcome is probabilistic rather than definitive. This can give the illusion that the LLM is talking to you, but actually it's simply following trains of thought. And the results are very impressive. Whatever your view is on whether they're intelligent or not, LLMs like ChatGPT have genuine utility in finding information. So, if AI gets so powerful, will we still need engineers? Well, let's think science fiction. Warhammer 40,000 is a fun game set in a fantasy universe where there's been civilizational collapse and invasions from all sorts of extraterrestrial powers. It's the year 40,000 and no one understands anymore how to use machines that were developed in the golden age of technology. So there is a class of tech priests who operate machines on the basis of prayers, incantations, and hope. It's a fun game, but none of us would want to live in that universe. Similarly here, no matter how clever the AI gets, there must be human validation. If we blindly trust results from AI, then it stops being a science and starts becoming a religion. Or to put it another way, imagine walking over a bridge across a tall chasm. Would you want it to be designed through proper calculations or by prayer? With the advent of AI, it's now possible to write essays and even have it code for you. So the question arises, is it cheating? Throughout our history, we have created things to improve our productivity. AI is no different. The engineering design process starts with an idea, then a literature survey, then a system design, component design, then testing and final reporting. Throughout this process, we can use AI to enhance our speed and efficiency of delivery. We can use AI to find the best papers and the key facts. But note, you must always check whether those facts are actually in the papers. Sometimes AI will create a fantasy. So tools like Perplexity are very useful, but you can't trust them 100%. Similarly, we can use AI to significantly speed up our coding and shortly also our circuit designs. But testing and evaluation will still be needed. So AI is helpful, but we still need to ensure that it's correct. And therefore, it's not cheating as such, as long as we deliver something that is properly tested and verified. It's just a different process than what we've used in the past. It goes without saying that cheating and plagiarism is wrong. 1. Always write in your own words. Do not copy and paste. Do not copy, paste, and rearrange. Write what you think is the correct statement. 2, anything, whether text, imagery, equations, anything that comes from another source must be referenced. You should view this as a positive. You get marks for doing good literature searches. Also, if you state something wrong, you will get marks subtracted. But if your incorrect statement is referenced from a reputable source, then it's the source's fault, not your fault. So all assignments will go through a plagiarism checking system called Turnitin, which will compare what you've written to everything else that has ever been written and is freely available on the internet. And it will tell us if you have plagiarized, including potentially the use of AI. Imagine you're an employer and you have to choose between 2 engineers. One engineer uses AI to write code in a day. The other engineer is highly intelligent and loves to do it themselves, but it takes a week. Who would you choose to employ? When you consider it, we cannot ignore AI. In fact, it's critical to your career that you learn how to use it effectively in your design flow. The good news is that if an AI engineer can produce 5 times more valuable goods and services with better tools, then there's also scope for higher wages. The second important note, imagine if you are abseiling off a cliff. Which knot do you trust? Do you trust A or B? Now think about it for a minute, why you made that decision. For anyone who has done abseiling before, the answer is quite obviously A. A is understandable. You can follow the rope. You can determine immediately that it will not come loose as you jump. B, on the other hand, is hard to follow. It might be strong, or it might immediately fail, but you cannot tell from the picture. And the rule in climbing or abseiling is that you never trust a knot that you do not understand. And the same is true for engineering design. It needs to be explainable. It needs to be possible to determine whether or not it will fail under certain conditions. Otherwise, we cannot trust it. The first demonstration I'd like to give is for literature searches. I'll leave the slide for you to read. Also, at the end of the presentation, there's a list of AI tools that I recommend to support your searches. This is IEEE Explorer. This is your classic search tool for looking up research papers. So if, for example, you are trying to explore power management systems within some microelectronics or embedded systems framework, you could look up, say, buck converters. Yeah. Buck converter is something that sort of brings a voltage from a higher domain down to a lower domain. And you could, for example, say, right, well, I'm only interested in journal papers, and you can sort of search through, all of these different results. You could say, well, 128 results is a bit too much. So you could say, well, I'm only in, 5 volts to 1.8 volt. Let's imagine that you're trying to go from a USB 5 volt domain down to like a 1.8 volt domain. Buck conversion. It can then sort of cut down those papers into perhaps just a few papers for you. And this is your traditional search tool that you would use to do your literature survey. When you use AI tools, however, it's something different. You typically give it context. So you could say, I am trying to develop an embedded system. You could even say medical embedded system or IoT system, doesn't really matter. What is the power efficiency for a buck converter converting from 5 volts to 1.8 volts? So you notice here, this is not looking up research papers per se. What you're doing is you're actually asking it a specific question. And in this case, it'll actually try to answer that question. Now, what you'll notice in this scenario, if you simply ask it this question, it'll refer to maybe a reputable source, but maybe not. What is this thing, this Hajim? This is some kind of piece of work. It looks like it might be some conference paper. I would never trust anything written in a conference paper. Really, journal papers are, the gold standard. So you could say, I'm trying to convert from 1.8 volts, from 5 volts to 1.8 volts, and you could then say, refer only to research journal papers. Yep. Doesn't always obey you, but sometimes it will give you a different result. So for example, in this case, you've got a reference from Texas Instruments. You've always got to be a little bit careful with, these kinds of sources. Manufacturers will lie to you as well, but they're probably a bit more trustworthy than something you'd find in a conference paper. And you can then look through this. You can do a search for the particular question. The second demonstration I would like to give is using AI to support coding. Again, I will leave this slide for you to read and progress to a live demo. At the end, there's a list of AI tools that I recommend for maths and programming. This is Claude. It's, in my view, one of the best of the programming tools that you can use using AI. Now, let's consider it using a small, simple programming project. Let's imagine that I've just copied and pasted the text in. Now, what you notice is that you have to give it some context. I'm doing a project to develop an Internet of Things device to control a small bipedal robot and ensure it's standing up. It includes a microcontroller that receives a signal from an inclinometer. That's a device that determines the angle. The signal goes to the microcontroller, ADC, and then into a PID algorithm to determine whether the robot should lean forward or backward to stay balanced. Please write me some C code to achieve this process. If we then click return, what you'll notice is that it then gives an explanation, it thinks for a bit, and then it generates a full set of code. This code, I've asked it to be in C, so this code's in C. You can ask it to be in Arduino, Python, or any other particular language. So for example, if I say, please write this code in Python, it will then rewrite the code into Python for us, as you can see here. So this is an absolutely superb way to support your coding. Now, as I've always said all the way through, remember, it's there to support you. It's there to help you code quickly, but you still must understand this. Do not just copy and paste this code and just accept what it's doing. You must then go through line by line and make sure you understand it. If you don't understand it, you can't trust it. Another particular approach to this is actually inline AI coding. So you could, this is now Visual Studio. You could, for example, say, okay, let's make a new Python code. This Visual Studio has something called GitHub Copilot, which you might see here at the top, already installed. And what you can do, I'm just going to copy and paste the same thing again. I am doing a project to develop an Internet of Things device to control a small robot. Yeah, I'm just going to take this down and so that it's all readable. And then if you wait, it's actually started generating some more comments for you. This is not me. This is the actual AI generating it directly. And then it thinks for a bit. and it will start generating code in line. I'm not typing here. This is just suggesting code. I'm pressing tab and enter, and it is generating the code for me. So as a mixture, so I definitely recommend this. This is very, very powerful. Using GitHub Copilot, the more code you develop in the actual program, the more it understands what you're trying to do, and the more it can make some predictions and some suggestions about how to improve what you're doing. If you mix the two processes of using Claude, what we saw before, and where you start off, you take some big chunk of code. You can take this big chunk of code, you can copy the contents, you can put it, for example, into your Visual Code or whatever other tool that you're using to program, and then you can use the automated inline system, whether GitHub Copilot or some of the other systems like Cursor, to actually then support your coding further. And when one makes a mistake, the other sort of steps in to suggest alternatives. So these two are very, very powerful methods to actually support your programming. The third demonstration I'd like to give is using AI to support maths activity. So this is an equation. It's the relation between the transconductance of a MOSFET transistor and its width and length and drain current. One of the fun things that you can do using AI is to load it in to something like Claude. Again, I've got a certain preference for Claude. And you can ask it, this is a relation for a MOSFET. Don't give it any more information and say, please derive this equation. And out pops, it immediately recognizes the image shows an equation related to a MOSFET field effect transistor. The equation is, so it basically repeats the equation that it sees. This is an image, this isn't text. So it recognizes the text, it defines the variables, and then it will derive the equation for you. You can even, if you want, then say, please write me some Python code to demonstrate this relation in a graph. Yeah, and it will then generate some Python code for you, for example. So this is a really fun way to deal with mathematics, where you can get it to derive an equation that you've written down and actually support your understanding of particular mathematical algorithms. Another situation that you can have is where you don't even know an equation in the first place. And you could ask it, for example, please give me the relation between the output, or not even between, but please give me the relation for the output, if I can spell it correctly, resistance of a MOSFET transistor in a small signal, or a small signal model. It'll understand. It'll think for a bit, and it will immediately derive that equation for you as requested. It'll also come up with more complex relations depending on what you particularly need. You still have to check to make sure everything is correct. You're an engineer. You can't just have faith in systems, but it is incredibly useful at supporting you developing things quickly. The final demonstration is using AI to generate art for your thesis, poster, and bringing engineering concepts to life. There are many different art tools out there. The most convenient to access is actually Bing, which comes free with the Microsoft Explorer. One of the things you could do is say, draw me a hand holding a computer chip with a glowing LED on top. And what it will do is it will think for a little bit. It does take a little bit of time. And then it will draw an image for you. And it's worth noting at this stage while we're waiting that all the imagery in this presentation has been developed by, by basically DALL-E, which is this particular, which is the core imaging tool here in this program. So as you can see here, this may be or maybe not to your liking. Another possibility is that you could, for example, draw me an image of a scientist in a lab testing some electronics. The scientist should be female and in her mid-30s. I don't know, depends what age you fancy. Should have black hair and be wearing a white lab coat. And again, it'll take a little bit of time and it will develop, the image as required. There are more advanced imaging tools out there, such as Midjourney, Leonardo, etc. But as you can see, this is pretty good as a basic tool to generate some images for your text, to make your thesis look nice. In summary, AI is a productivity tool. Your future employers will expect you to have higher productivity than workers in the past, but you need to know how to use it properly. You must understand what's being created, tested, and know whether it's correct or not. And you must explain your work, that your work was generated by AI and how you tested to make sure that it was correct. I'm Patrick Degener. I hope this has been informative. And if you have any questions or feedback, please contact me at patrick.degener@newcastle.ac.uk.